This is my AP Biology fall final project. This is a 3D model of my enzyme, creatine kinase. Creatine kinase, otherwise known as CK, helps supply energy to cells throughout the body, particularly muscle cells. CK naturally occurs in red meat and fish, it is made by the body, and it can also be obtained from supplements. 8 foods that are high in creatine are red meats like steak, venison, and pork. The next highest would be fish, including salmon, herring, tuna, and cod. And the lowest would be white meat like chicken. Creatine kinase is thought to improve strength, increase lean muscle mass, and help muscles recover more quickly. CK may help athletes achieve bursts of speed and energy, especially during activities such as weightlifting or sprinting. I chose creatine kinase because I take it on a daily basis, so I wanted to better understand what I'm putting in my body. Some people say CK should be banned, arguing that it's a performance-enhancing substance that may add an unfair advantage. So I wanted to see if my perspective on creatine kinase would change after completing this project. This is an image of the creatine that I use at home. This is a video of me putting creatine into a protein shake, and every day I put 5 grams in. Creatine kinase is an enzyme that helps maintain the concentration of ATP within a cell. In order to do so, creatine kinase catalyzes the movement of a phosphate group from ATP to creatine, forming phosphocreatine. This molecule is stored in the phosphate group, acting as an energy reservoir. Cells that have high ATP requirements have higher levels of creatine kinase. This image shows creatine becoming phosphocreatine and ATP becoming ADP. This image shows a person at rest, so he has phosphocreatine stored and ADP. It then becomes creatine and ATP, which can be used as energy to do work. The energy of ATP must be held in phosphocreatine because ATP must remain within tightly regulated concentrations to preserve the function of various biochemical pathways. The energy held in this phosphate group can be efficiently and quickly converted by creatine kinase either to or from ATP. When there is too much ATP, the enzyme lowers the concentration by converting ATP to ADP. It stores the extra phosphate in a creatine molecule, creating phosphocreatine. As the mitochondria produces ATP through respiration, the energy transfers to phosphocreatine molecules, which goes to the cytoplasm of the cell. The cytoplasmic creatine kinase can then release the energy stored in phosphocreatine by creating ATP, allowing the cell to capture this chemical energy. This image is similar to the last two because it shows creatine phosphate becoming creatine and ADP becoming ATP through muscle contraction or work. In the digestive system, the body can naturally produce creatine kinase. It's made primarily in the kidneys and completed in the liver. In the muscular system, the body converts CK to phosphocreatine and stores it in your muscles where it's used for energy. In the reproductive system, creatine kinase increases ATP levels in sperm. In the urinary system, creatinine, or the breakdown of creatine phosphate, is a chemical waste product produced by muscle metabolism. When your kidneys are functioning normally, they filter creatinine and other waste products out of your blood through urination. This image shows the different human body systems. Creatine kinase taken in high doses is possibly unsafe and could cause damage to the liver, kidneys, or heart. CK can cause muscle cramping, nausea, diarrhea, dizziness, dehydration, weight gain, water retention, heat intolerance, or fever. This is a diagram of the side effects of creatine use on a human body. I believe creatine kinase is an interesting topic because people think that it is a way of cheating because you get much more muscles without less work. But in reality, it is simply an enzyme that is naturally produced in the body and is used to recycle ATP in muscles. It amazes me that many gym bros only know the surface of CK because they see it as a powder that they put in protein shakes to help gain muscle mass. To represent gym athletes, This is a very basic representation of how creatine works. So it starts off as ATP, which is energy for your body, and once the energy is used, it then becomes ADP, and then you recycle the process by just adding creatine powder to your protein shake. This is a screenshot of my notes. So on November 16th, I started taking creatine, and at the time my bench press max was 180 pounds for 1 rep, and my back squat max was 200 pounds for 12 reps. On December 12th, a couple days ago, or my most current lift, my bench press max was 200 pounds for 1 rep, and back squat max were 315 pounds for 1 rep. The overall improvement after taking creatine was a plus 20 pounds in bench press and a plus 30 pounds in back squat, roughly. Overall, I feel stronger and healthier after incorporating creatine kinase in my daily diet. I probably wouldn't have been able to notice such an increase in bench press or back squat in such a short period of time if I hadn't taken CK. After independent research and completing this project, I still don't view CK as a performance-enhancing drug. If anything, I believe all athletes should use creatine kinase because it allows for muscle growth in a shorter period of time, and it aids in muscle recovery.